Okay, so keep up the heat. Okay, so my question is, how is mechanical energy used in the laws of thermodynamics to convert to kinetic energy in an airplane's engine when it accelerates? So these laws basically are applied with inside the engine itself and work with heat. So the laws of thermodynamics is the relationship between energy, work, and heat, and it helps with the transfer of energy from one location to another. So the first law is there's two systems within a thermal equilibrium with a third system that is used as a temperature scale. And the second law is most similar to the law of conservation of energy. The system's internal energy is equal to the difference from heat implemented from the atmosphere and the system and the work done by the system. The third law is heat won't flow from a cold area to a hot one, and the heat at a specific temperature can't convert completely to work. So there's some heat lost within the system. Okay, so there's some terms you need to know before diving more into the subject. So first is mechanical energy. We're all pretty familiar with it. It's the power that an object gets from its position and motion. It's also the addition of kinetic energy and potential energy. Mechanical energy stays constant throughout a system. It's measured in joules, and it's made from heat using the laws of thermodynamics. Also, kinetic energy and how it's energy made by being physically in motion, also measured in joules. Okay, so a heat engine. Heat engine is what a airplane's engine basically is, and a heat engine takes a high temperature source of heat and converts it into work like mechanical energy. So you see these things in this picture here on to the right. It's like these cylinders sticking out. Those have pistons inside of them, and when a small amount of gasoline is put into those closed off cylinders, the piston crushes it and creates like a small explosion, propelling the piston out, which emits heat transferred into mechanical energy. When the pistons move in like the correct order, they make the center right here of the engine start spinning, and when it spins very fast, you're able to attach like a blade to it, and the blade's able to spin and it push the plane forward. Because the planes travel at such a high speed and weigh a lot, a heat engine is the most successful is that the right word, successful? It's most useful because they create lots of energy using heat, and they're able to withstand high temperatures. Okay, so there's some more stuff about heat engines. There's 4 steps that go into the process of turning heat into energy using the laws of thermodynamics. So the first step, this is when gas is heated and it creates pressure that expands, forcing the piston to move up or back based on how you're looking at it. Also, when something goes from having no temperature change to a higher temperature change. So the second step, this is heat. This is when the heat of the gas doesn't change to a lower temperature. And then that creates the expansion. In the third step, this is the process of cooling the pistons. This makes the pistons retract back to its original position before the gas was used. And the fourth step, this keeps the cycle between heating and cooling and makes the pistons move back and forth. So when the heat goes to a lower heat, it creates work, shown in the picture on the far right. Okay, so after learning about the heat engines and how they're used and what's the process that makes them work, I could finally answer the question, how is mechanical energy used in the laws of thermodynamics to convert to kinetic energy in an airplane's engine when it accelerates. So mechanical energy is used in these laws when the heat is present, so high temperature heats, but best illustrated in the heat engines shown in the last few slides. Mechanical energy is converted to kinetic energy when some kind of fuel source ignites the pistons to start moving and to create two different heat sources that react to each other to make the energy. Not really heat sources, but heat temperatures. So higher heat and a lower heat. Like most machines, some heat or some energy is lost throughout the process of the heat engine, or any engines really. So it's not completely efficient. So just a couple more things. Once the pistons inside the engines start moving faster and faster, they're using the process that I explained a couple slides ago. Makes that shaft in the middle start spinning faster and faster, and you can attach something like a wheel, but in this case a blade. Like cars use this kind of thing too, kind of, maybe, not sure, but in this case you attach like a blade to it, which would spin really fast and propel the plane forward. Yeah, so that's it. So here's the all my work I used, all the works cited. There's quite a lot here. I have probably about 4 photos, and some of the photos are like massive links, but I had to go on to like 3 slides, but it's all good. And yeah, that's it.